Recently I was listening to a book on Audible about the Monty Hall problem. It was a game show back in the day. The game show, basically, you had three doors. In those three doors, one door would yield a prize. So it could have been a car or a vacation or something like that. And the other two doors had nothing of interest. I think the game show actually had goats. So in this case, door A has the prize, door B and C are the goats. So considering the probability here, if it's purely random and you have no idea where the prize is, even though you might have some intuition that is probably not true, you have a 1 in 3 chance of getting it right, which means that you have a 2 in 3 chance of getting it wrong, which means that you're twice as likely to be wrong every time you pick than you are to be right. When you pick, I'll come back to this slide. When you pick, Monty Hall is going to open one of the doors with the goats. So you don't know if your pick had the goat or the prize, but you know this other door had the goat. So you're left with two doors. One is the door you picked, which could be right or wrong, and then the other door is the remaining one. So if you're right, the other door will have another goat in it, and if you're wrong, the other door will have a prize in it. At this point, Monty Hall asks you, do you want to change your mind? So start here. If you assume that your first guess is wrong, which it will be most of the time, then the door that you are left with, which is door 1 and door 2, other than the one you picked, must be right. What that means is, let's say I picked door 1. That was my first guess, and I'm going to immediately assume my guess is wrong. Monty Hall opens out door 3. We know that it's wrong, so I'm left with door 1 and 2. And again, I'm assuming my door is wrong. So I'm going to switch and go to door 2. This will be the case 66% of the time, that door 2 in this scenario will be the answer, strictly because you had a 66% chance that you were wrong. So the other side of that is that you could be right. And if you do switch your guess and you were right, then of course you won't get the prize. But this will only be the case 33% of the time. So keep that in mind. What's really cool about this is the initial guess, going back up to the top, you have a 1 out of 3 chance of getting it right. If you swap your answer at that second stage, then you've automatically changed your likelihood from being 1 out of 3 to being 2 out of 3, because you're assuming that you're wrong. So it's a very fancy, fun way to play the game. In addition to that, I made a little, here we are, a little program that will actually run us through. So hopefully it'll work this through here. So basically what you're going to do is have doors 1 through 3, and you're going to have an answer. In this case, it selects an answer of door 3. And I'm going to have the right door is door number 3. Here, we're going to loop through 1,000 trials where we just select a door at random. And the answer will be the answer that was up here. And we're going to see how many times we get it right. So we got it 343 times out of 1,000, which is really close to 1 out of 3. Well, let's assume that, let's see how many times we get it wrong. So again, it's going to be unrelated to the first round. Well, we got it wrong 67.9% of the time, which is again pretty damn close to what we were expecting. Well, I made a wonderful function here which will remove a door at random that is not the correct answer and is not the selection that you made. So hopefully I got it right. And here we're going to see what happens when you're forced not to change your answer. So your first answer will be the answer you're stuck with. Well, we got it right 340 times. Okay, well, what happens if you are forced to change your answer? So in this case, you make an answer, the Monty Hall removes the door and then says, do you want to change your answer? Well, we'll say yes. So we do it and we get it right 671 times out of 1,000, so 67.1%. So which is really cool about this, because you've literally played to your favor just by looking at the assumption that you're probably going to be wrong. So I think that's pretty dang cool. Anyway, I hope that was interesting to you guys. I hope that explains it to anybody who hasn't figured that out.